Good day, my name is Brian, and on the behalf of Team Danger Stars, we would like to present our project to you. If I had to describe our project in a sentence, it would be this. Project Queen Reefs is a project that aims to mitigate the effects of coral bleaching through the measurement of ocean temperatures and salinity levels in order to find suitable areas for coral replantation. But what is the current problem? Coral reefs are worth 29.8 billion US dollars over various industries. But yet, there's a devastating trend. The proportion of corals being hit by bleaching increased from 8% in the 1980s to 31% in 2016. In fact, it is estimated that 70 to 90% of all corals will be bleached in the next 20 years. What causes bleaching? Bleaching is caused by rising global temperatures as well as changes in salinity levels. What makes corals so valuable, though? Coral reefs take up 239 kilometers squared on the Earth's surface, but it's less than 1% of the Earth's surface. But yet, they are a huge carbon sink, absorbing 70 to 90 million tons of carbon annually. They also provide places for fishing, providing 9 to 12% of the world's edible fish. And they protect 150,000 kilometers of coastlines. But yet, when they are bleached, they cannot do this anymore. Some of the current solutions include artificial reefs, but they are unreliable and can lead to fouling, which is essentially the adhesion of foreign material to a surface, which may damage the surface, such as damaging boats or slowing boats down. There are also other ocean drifter programs, but they don't target corals or coral-hairy aviators, such as Indonesia. So how exactly does our project work? Our project's main idea is connecting ocean drifters with iridium satellite systems in order to find areas with rising sea temperatures and acceptable salinity levels. This is in order for us to carry out the replantation of corals in these areas so that less bleaching will occur. You may be wondering, what exactly are the precise conditions of the death? Corals die due to bleaching at temperatures over 29 degrees Celsius and under 23 degrees Celsius, as well as at salinity levels out of the range of 32 PSU to 42 PSU, PSU being practical salinity units, which are equivalent to 1 part per thousand, or 1 gram of salt per kilogram of seawater. These ranges are very small, and corals can die very easily due to bleaching. These affect the specific growth rates of corals, which are essentially how fast a coral grows. Moving on to our timeline, our project goes through 4 phases. It begins with the building of our subsystems, moving on to the usage of these subsystems to gather data, and then using this data to replant corals, and last but not least, to ensure the success of our solution. This whole process takes about a maximum of 3 years and 4 months. Moving on to the first phase, in the beginning, we start by building of our subsystems, which takes about 2 weeks. Then after we build the systems, we have to ship them out, which may take about 4 months. We have chosen to ship them out to Hawaii, as it is our area of focus. After that, we deploy the drifters into the sea, which may take up to 3 days. Let me start by talking about our subsystems. Our first subsystem, the drifter, drifts with the aid of a drogue. It measures sea temperatures using its temperature sensor and by recording a time series of water temperatures. In order to track ocean salinity, it uses a salinity sensor. These drifters also have communication devices that allow it to connect to a satellite, allowing us to collect data without having to retrieve the drifters themselves. Moving on to our second subsystem, the imaging tool. We built this imaging tool in phase 1, and it uses 3D underwater cameras to record stereo imaging in order for us to visually monitor these corals. Moving on to phase 2, every 6 hours, drifters and satellites will communicate, sending ocean data over to us. This goes on for about a year, and we spend about a week analyzing this ocean data. It's a pretty quick phase, and we move on to phase 3. where we start with replanting of corals, taking about a week. After that, we move on to the visual monitoring of these corals, which also takes about a week, but we do this with our 3D imaging tools. This is all carried out simultaneously with our conservation program, which is very important as it protects these new replanted corals. So how exactly do we go about this replanting of corals? We replant them by having divers sent down to attach them to the reefs piece by piece, using cement, zip ties, and nails. This is especially important as artificial reefs can be unreliable and cause harm to marine lives, the reefs themselves, as well as ecosystems. The specific genus we have chosen to replant are the Boretis corals, because they have the highest survival rates in bleaching incidents due to their massive frame. The particular area we have chosen is the Kaanaohebe in Hawaii. Among all the suitable areas, it has the smallest area of 45 kilometers square, which makes it a pretty good place to start. Also, 80% of the corals in that area are facing bleaching, which means we have a lot of replanting that we can start out with. 48% of the area are covered by corals, which means we can do a lot of observation there. And the rough estimate of the amount of corals required is about 17 million pieces. The particular Boretis species that we have chosen are the Boretis compressa, because they are native to Hawaii, and we believe that by replanting them there, it will not affect the ecosystem too much. Our conservation program involves a partnership with the NOAA, the National Oceanic and Atmospheric Administration. This involves the education of the public as well as the adaptation of their social science program in order to enhance our conservation. This is especially important as outside effects can impact our research and our replantation. Moving on to the final phase, where ocean drifters just continue to roam. It will continue for about a year, where we'll continue the observation of both the current corals as well as our replanted corals. After that, we'll spend about a week finding the relationships between the coral mortality rates with our replantation efforts. This will all come together to determine if our project is a success or not. What exactly are our success criteria? Firstly, would be the percentage annual mortality rates of corals, and secondly, Boretis corals growth compared to a 10 cm benchmark. Why 10 cm benchmark? Boretis corals are branching corals, and branching corals are estimated to grow about 10 cm annually. Therefore, by measuring the Boretis corals growth in the year and comparing it to 10 cm benchmark, we can see just how much growth these corals have had compared to the expected amount of growth. And therefore, we can see if our solution is successful. Moving on to the cost of the first phase involves the ocean drifters as well as our 3D cameras. It adds up to a total of about $11,000. In our second phase, it involves the cost of a satellite and the transmission costs of the satellite, which adds up to about $5,000. In the third phase, it adds up to a much larger number due to the conservation program as well as the replantation being a bit more expensive, adding up to $378 million. In the final phase, the costs only refer to the daily transmission costs, which also add up to about $5,000. The grand total is about $378 million. Despite this cost, there is still a huge profit to be made, as it is estimated by the UNEP that there will be a net profit of 35 billion US dollars should the reef situation in Mesoamerica change for the better. Overall, to recap, our project aims to mitigate the effects of coral bleaching through the measurement of ocean temperatures and sea salinity levels in order to find areas suitable for coral replantation. We sincerely hope that you will invest in our project and save the reefs today. Thank you and have a nice day.